Hello, good morning and good afternoon to everybody in the room and to all our guests who are joining us online. Welcome to our third Europe-China workshop on clean energy transition. I'm Julia Metz. I'm lead industry policy at Agora Energiewende in Berlin, and I have the honor to guide you through the event this morning. For all of you who weren't able to attend our workshop yesterday, let me say a few words about this workshop. This is the third Europe-China workshop on clean energy transition, which has taken place so far, and for the first time it's taking place here in Berlin. And the event is co-organized by our colleagues in Beijing, from Agora Energy Transition China, by us, Agora Energiewende, by the GIZ, the Deutsche Gesellschaft für internationale Zusammenarbeit, and by the Shaanxi Province Energy Research Institute, as well as, I was told, the Shaanxi Dual Carbon Research Institute. And this year's workshop focuses on shared net zero prosperity for an inclusive and sustainable recovery. So we are focusing on common goals and pathways to achieve net zero prosperity. And this workshop aims to promote in-depth Europe-China cooperation at local level and in key sectors in support of an inclusive and sustainable economic recovery. Yesterday, the focus of the workshop was on power sector decarbonization, and we discussed rather, I would say, technical topics such as demand side flexibility, and also fundamental questions of the energy transition in coal regions. Today, our focus lies on industry decarbonization. And today as well, we're going to focus on more fundamental questions of the state of play of industry decarbonization in Europe and in China, and also maybe more specific questions coming to trade issues and the European CBAM, the Carbon Border Adjustment Mechanism. Our workshop has simultaneous interpretation and is broadcast live in mainland China at the same time. For all of you who want to make use of the interpretation, channel 1 is for English and channel 2 is for Chinese. Now, before giving the word to Markus Wiepio from GIZ China for some opening remarks, I would just make a comment, like from my perspective of my work focus. The focus of my work lies on industry decarbonization at national level. So I'm very much involved into appropriate instruments that foster the industry transition at national and also European level. However, in order to for Germany to be successful here domestically, the cooperation with strong partners in other regions with strong industrial bases is crucial. And that's why I'm very happy that today's focus lies on the industry sector, where a lot of dynamic can be observed right now, and it's so important for us to join forces to push industry into making the right choices and investment decisions towards climate neutrality. And in this sense, I look very much forward to insights and inputs by many energetic people who are working on the field of industry decarbonization. And with this, I would like to welcome Markus Wiepio, who is project director of the Sino-German Energy Transition Project at GIZ in China. Please give him a warm welcome.
Thank you very much. Dajiahao, Caoshanghao. Good morning, everyone. I feel very honored to have been given the privilege to deliver the opening remarks this morning for the second day of the third Europe-China workshop on clean energy transition. Yesterday's session was focusing on the establishment of a reliable, secure, and renewable-based energy system. In both countries, China and Germany, the installed capacity of renewable energy generation sources has already crossed 50%, and the share of renewable energy in the electricity mix is rising fast as well. Most of you are probably familiar with the characterization of the International Energy Agency, IEA, of the 6 phases of the energy transition. So the first phase is where you have very little renewables in the system, and actually you can just go ahead as before. And then ranging to the 6th phase, where you are completely, fully on renewables, and that of course requires a complete different approach. Both China and Germany are now somewhere between phase 3 and 4 of this categorization, which requires major changes in the power system to bring in more flexibility. In principle, it is a complete reversal. Renewable energy becomes the major source of electricity, while thermal power assumes the role of backup power. This also has a huge impact on coal regions, and I'm very impressed by the achievements already made in China, and in particular in the province of Shanxi. I have already seen myself how dependent provinces like Shanxi and Inner Mongolia are on coal dependent, and therefore due to the magnitude and scale in China, there are definitely huge challenges ahead. Germany has a lot of experience to share in this regard, and therefore it is great that this international exchange has been established as part of the Taiwan Energy Low Carbon Development Forum. For a successful energy transition, the interventions and changes need to address both the supply as well as the demand side. Today, we will therefore be discussing the decarbonization solutions for sectors and enterprises. I don't want to preempt any conclusions from the upcoming presentations and would like to draw your attention to the main motivation for this event instead. The recent increase in extreme weather events all over the globe is an early warning sign that we need to stop to emit ever more greenhouse gases into the atmosphere. 20 years ago, it was still believed that an increase of global average temperatures of 2 degrees centigrade at the end of the century would be safe enough to protect our habitat from drastic changes in the global climate. However, now it becomes more and more evident that already now we are crossing critical limits which can trigger irreversible tipping points with vast consequences for our own generation and, of course, also for the future generations. I myself believe in technological progress, but it takes time, and time is what we are running out. In order to maximize our efforts, it should be in everyone's interest to focus on what he or she can do best. China has developed huge manufacturing capacities for solar, and the availability of cost-efficient solar panels has become an important driver for the energy transition. China has also demonstrated at home how to build the business case for electric mobility, while there are other technologies developed in Europe which can help in accelerating China's energy transition. Common standards support faster dissemination of technologies, while sharing successful experiences and learning from each other reduces the time and cost for adopting successful solutions. Only international cooperation can ensure that the full potential of mankind's capabilities can be put to use and that we minimize the damage already done to the global climate for ourselves and future generations. The Montreal Protocol on substances that deplete the ozone layer, which was established 36 years ago, can serve as an example that we can do it. I'm therefore glad that we have the Sino-German Energy Partnership, which can support the exchange between Chinese and German think tanks through studies and events like this one. The Sino-German Energy Partnership has been established already in 2007, and it is the central platform for energy policy dialogue between Germany and China on a national level. Recently, on June 20th this year here in Berlin, on the occasion of the German-Chinese intergovernmental consultations, both the German Federal Minister of Economic Affairs and Climate Action, Robert Habeck, and Chen Changji, Chairman of the National Development and Reform Commission, NDRC, emphasized the cooperation by signing a memorandum of understanding on the establishment of a dialogue and cooperation mechanism on climate change and green transition. It contains 8 fields of action for cooperation, including decarbonization of industry, expansion of renewable energy sources, circular economy, and the issue of sustainable financing. This dialogue and cooperation mechanism will draw on and expand the existing formats to increase efforts. The launch of the Climate and Transformation Dialogue is thus a strong signal that China and Germany acknowledge their responsibility to take climate action, and that they are willing to continue the cooperation. The Agora team has done a wonderful job in preparing an exciting program and inviting renowned experts for this workshop. I'm keen to listen to the upcoming presentations, followed by fruitful discussions, and wish everyone, and this of course includes all the participants who follow the workshop virtually, an interesting and enlightening event. Thank you.
Thank you, Markus Wipior. We now have the pleasure to listen to 3 keynote speeches. We have organized them rather as impulses, which means that we won't have a Q&A sessions in between. So for all of you who are with us joining the event in person, feel free to contact and talk to our speakers later on in the coffee break. Now, let me first welcome a dear colleague of ours, Professor Stefan Lechtenböhmer. He has been a key figure working on industrial transition at Wuppertal Institute for almost 30 years. And I can actually also say that he has played a relevant role in building up Agora's work on industry decarbonization. And he has just assumed a full professorship for sustainable technology design at the University of Kassel at the newly funded Institute for Sustainability at the beginning of this month. Stefan Lechtenböhmer, the floor is yours.
Yes, thank you. Julia, for the welcome, for inviting me here. Thank you to all participants, and also particularly many thanks for your warm words. I'm honored to be here, and let me maybe start. I think it's very clear to everybody here, and Markus Wipior already announced it, that industrial decarbonization is a very important topic, and we really have to work for it. It's particularly urgent, and I think everybody who has read the IPCC reports is also aware that industry is a very big greenhouse gas emission polluters. And that holds particularly true for the energy-intensive basic materials productions. So to name it concretely, steel production, basic chemicals, petrochemicals production, cement making, and alone these 3 sectors emit roughly 20% of global CO2 emissions, which is really a lot. If you take the rest of the industry and the indirect emissions on top of it, we are really talking about almost 40% of global greenhouse gas emissions. And of course, we all know, different from other sectors, we will need much more steel, cement, plastics for a sustainable future as well. So demand is not going to decline, but rather rise, particularly globally, not in Europe, but on the globe. And so the decarbonization of these heavy industries, which are really the physical conversion of materials, use a lot of energy, do emit a lot of CO2, and that's really an important issue to tackle now. I think that's the first point. It's really important to go for industry, because that's sometimes it has been termed hard to abate sectors, these heavy industries. I think we are beyond that already and can do more in these sectors. Oh, great. I'm seeing the slides. You see them as well. Okay, here you can see it in the slide on the left. You can see the relevance in red of the industry. And on the right, you can see projections by the IEA on how industries are going to grow, and demand for chemicals, steel, and cement are projected to grow in the future by 2030, but also beyond. And industrial decarbonization is not only extremely important, it's also Which button? Ah, yeah, that's okay, thank you. I can also sort of wave for the next slide. Industrial transition is also very urgent. And that's because, particularly in those heavy industries, we had really long investment times. So industrial assets that we build or reinvest today will last for decades, will also need decades to be repaid. And so every investment decision we take today is predetermining significant amounts of greenhouse gas emissions of the future. So, and on the left, we can see the situation in Europe. And here, roughly, of course, that's rough estimate, the main emitting assets of steel industry, chemicals industry, and cement industry, roughly 50% of these assets have to be reinvested or major refurbished in this decade, so in the remaining 7 years, roughly. And so this investment needs to be climate neutral, or at least climate neutral ready, if it doesn't want to become stranded assets in the near future when we really need to be climate neutral. And on the right side, we can see that it's not only a European issue, it also holds globally. There it's made for blast furnaces, the biggest emitting technology, I think, together with cement mills on the globe. And here we can see that by 2030, globally, over 70% of all the blast furnaces are bound to be reinvested. And that's, of course, huge. That's in Europe, but that's also a big share of that is in China. So next slide, please. So given that big challenge of investing in novel technologies, which most of them haven't been really tested at large scale. Most of them are not readily available at the markets. We can see that at least European steel industry has announced to live up to that challenge. On that graph, we see announcement. It's already 1.5 years old, so in between there has happened something. But there we can also see in yellow, it's the blast furnaces in European countries that have to be reinvested in this decade. And in red, we see announcements of clean steel making by the companies. So, and we see there is already significant announcement of going into that technology. Leading is Sweden. Sweden, of course, because there's lots of relatively affordable clean energy available, but also Germany has a lot of announcement, Netherlands, France. So Northwestern Europe, which is also the industrial heavyweight in Europe, is really leading the development. However, if you look at Germany, there is still a way to go because the issue is even bigger than the announcement to date. And then if you look to the right, there are a couple of countries which are still a need to follow on this route. However, if we look, for example, to Spain, there have been recent announcements there to go for it. Again, as in Sweden, Spain obtains of affordable renewable energy potentials. And so on the announcement level, industry is really going to go that route, reinvesting not in the existing technologies, but in green steel making. In Germany, for example, we have now seen the first investment decisions by big steel makers on that issue. Next slide, please. So beyond announcement, how is European steel industry, for example, going to make the green transition? And this is some results from a recent scenario study Wuppertal Institute did together with Agora and other partners. And here you can see on the left how European steel production will emerge in the future. It will be more or less stable. That's a slightly optimistic projection. And we see that first there will be a shift to secondary steel making, which is, of course, in the end, more resource efficient and also much more energy efficient than primary steel making. So the share of secondary will increase from something around 40% to almost 60% until 2050. And the remaining slightly declining primary steel making will shift gradually from the blast furnace route with coal and coke based to direct reduction technology. And you can see already by 2035, so in 12 years from now on, it is expected that a huge share of that asset base will already be converted, and by 2040, the conversion will be more or less achieved. So that's really ambitious plans. And if we now look on the right, what does that mean energy-wise? And here we can see there's, of course, some energy efficiency in the conversion, particularly to the secondary route. But we also see that due to the availability problem of green hydrogen, not all of the DRI steel making will be with green hydrogen in the first place. Some will be, for example, in northern Sweden, that's all green hydrogen based. But in Germany, for example, steel makers probably will start with natural gas for green steel making, which reduces emissions by over 2/3 already, and later shift to green hydrogen when the hydrogen is available, when the infrastructures will be available. And so there is an intermediate phase where the steel industry will probably use slightly more gas than it uses today. However, that will be compensated by savings in other sectors. And in the end, steel industry will be converted a lot to electricity, hydrogen, and also a significant share of biomass, which even opens up the potential for negative emissions in that sector. So that's the perspective here, energy-wise, for the steel conversion. And now I would like to present you another very important sector, that's chemical industry. And also for chemical industry, it's a big challenge to defossilize. Chemical industry is the second largest energy consumer in Europe after steel industry. And here we can see in that figure on the bottom, that's what we traditionally call energy use. So chemical industry in Europe basically today uses natural gas and a lot of electricity and a small amount of other energy carriers. The industry will convert or reduce natural gas use very significantly in the next years. So by 2030, we estimate that gas use will be only 50% of recent levels. And by 2040, it will be completely phased out in that scenario. And most of that will be taken over by electricity. That's a lot of heat and steam demand. Electricity will really become the bulk energy carrier for chemical industry. However, in chemical industry, it's not only about decarbonizing energy supply. It's also about converting the resource base, which is currently, of course, mainly oil-based. Some ethane in the steam crackers, so all fossil, and of course natural gas for ammonia and other projects. And so the oil-based, fossil-based feedstock is also on the long run a problem, because in the end it also gets emitted into the atmosphere and is fossil carbon. So the chemical industry also has the challenge to convert its fossil resource base to a renewable resource base. That will be, of course, slower and even more challenging than the energy transition. And we foresee that it begin significantly by 2030 and then will be completed by 2050. And what are the main strategies for the industry to achieve that? That's using more plastics, so increasing the circularity in chemical industries, and that means physical recycling, but also chemical recycling of plastics. That means using biomass, more biomass than today, as a feedstock into chemical industry, as a new input into maybe new plastics, and synthetic feedstocks, which is basically methane and other feedstocks that can be created by non-fossil carbon plus green hydrogen. And you see that use will use a lot of hydrogen, which is given extra in the figure. So converting the industry, the asset base and the resource base of the industry will really be a big challenge. And it's, again, also opens up the opportunity for creating negative emissions when the plastics that are based on non-fossil carbon in the end may be incinerated and combined with carbon capture and storage. However, that needs a massive investment into the asset base of the chemical industry and also into waste treatment plants and methanol-based resource route. So that's also a really major conversion step. And of course, again, here costs will increase for the industry. Cost structures will see major changes. So that's really an important challenge which will change a lot in industry and puts them for strong challenges. So having seen these two important industry sectors, how they decarbonize, most of it will be green electricity. Another important part will be green hydrogen. The question, of course, arises, which energy, where can the energy come from for this transition? And I will first give you an overview of the whole industry. The question currently really relevant in Europe is, of course, the question of natural gas. We have seen in chemical industry, but also other industries, apart from not in steel making, but in the other industries, natural gas is today dominating. We can see in the figure on the left the situation in 2018, and in yellow it's the fossil natural gas. So roughly 50% of the energy used in industry was or is natural gas. And of course, the bulk of it is in medium temperature range and in high temperature range. And we see that over the future, the industry will also see a rapid decline of the share of natural gas, together also with reduced demand. Again, electrification will see in the overall industry an important role. Electricity will grow a lot, first in the low temperature range, where with heat pumps and other technologies we have very efficient options to use electricity for replacing natural gas and other energy carriers. And in the high temperature range it will take longer. One of the most important steps is then, for example, the steel industry, which is a very high temperature. Medium temperature range is more the chemical industries. And so by 2050 also we will see there a strong conversion to huge shares of electricity with a part of biomass playing a part of the role and a smaller role for hydrogen and other secondary gases. So where will this energy come from? You see on the left side the map of Europe with the additional electricity demand for climate-neutral steel, climate-neutral chemicals, and climate-neutral cement. So that's the bulk of the industry, the bulk of the energy demand of the industry, not the bulk of the industry, of course. Other industries are smaller and less energy consuming. And you can see in the dot that we are talking about something between 100 and 150 big industrial sites in Europe, where these energy demands are concentrated. And within Europe, the bulk of that is concentrated in one area, which is basically the Benelux, so Flanders, Netherlands, and the German state of North Rhine-Westphalia, which you could also otherwise term more or less the wider Rhine Delta. And that's the area where really the bulk of these heavy industries is concentrated, and also the bulk of the energy demands, future clean energy demands, is concentrated. So, and on the right, you can see the available electricity, green electricity potentials. And you see on the fringes of the EU, in Scandinavia, in the south, in Spain, there's huge green energy potentials, larger than the demand expected there. But in this northwestern part, of course, we have more demand, much more demand than available energy potentials. So the challenge for Europe is to create an energy infrastructure. And this is the idea of European gas TSOs. on a hydrogen backbone. Of course, Europe already has this strong natural gas connection, which can be repurposed to carry green hydrogen, and that's the ideas. However, to create such an intra-European hydrogen network needs a lot of time, and so it takes a lot of time. That's also one of the reasons why landlocked industries will first need natural gas until hydrogen will be available. I see time is up, but in the beginning I lost some time, so just give me some more seconds, because achieving all this, so the transition of the industries and also the related transition of the energy system is really a big challenge, and that needs an integrated policy package, and I will be quick on that. One last point, we will also see relocation of industries. Don't read this slide. There's already a couple of announcements in steel and ammonia of basic industries production moving to places with cheaper energy resources. A lot of that will happen inside EU, but there are also announcements outside EU, for example, to the Middle East, where there's also very cheap energy potentials. So we will also see that as part of the future industrial development. However, we need strategic policy bundles that need to really be integrated along the whole value chain. So need to take care on the availability of energy and resources for the materials, need to take care of efficient use in the industry, in the product design, in the demand side, on the one hand, on efficient use of the products, but also on the creation of green markets, and finally also take care of circularity, because circularity is, of course, the most efficient way of reducing greenhouse gas emissions energy demand in industries. And it needs to be integrated over policy fields, clearly target-oriented, integrate policies from climate over energy, industrial and trade policy, but also resource policy, and very important, I think, structural policy, because as we have seen on one of the maps, industry, as is coal industry, is very spatially concentrated. So it's certain regions that are particularly affected by the change. And in order to take them on board, we really need to integrate this also with structural policy, with ideas for these regions, for their economic development. And I think, that's my last slide, the European Green Deal has a lot of policies on all these fields, and so it's going really into the right direction, and I think the next Commission has a big job to do to really make that strategy work. Thank you a lot for your attention.
Yeah, well, thank you, Stefan Lechtenböhmer, for this comprehensive overview. And now let us turn to China. And let me welcome Dr. Li Bing, who's actually based in Beijing, but is now joining us from Xichang in Sichuan province. Dr. Li is director of the Low Carbon Development Research Center at the China Metallurgical Industry Planning and Research Institute. So she's an expert on transition strategies for metallurgical industries, such as the steel sector, which we just saw is one of the most energy and carbon intensive industries. As soon as Dr. Li is with us, please give her a warm welcome.
For your introduction. 我现在呢是在这个很遗憾今天没有到现场。
Unfortunately, I won't be here with you in Berlin. But I'm still contributing to the low carbon transition of the steel industry. I'm currently in Sichuan, actually a steel factory. You might hear some noise. That's the transporting vehicles going through. I'll take the next 15 minutes to share with you the progress and prospect of low-carbon transition in Chinese steel industry. The previous speaker also talked about the steel industry. Steel industry in China is the largest in the world, and the demand is the largest in the world. So I'm going to share with you the overview of the Chinese steel industry. I'm going to talk about the development status and stages of the steel industry in China. And second, the progress and prospect of low-carbon transformation. So part one. As you might know, since 1996, China's crude steel output has exceeded 100 million tons. It has been the world's largest steel producer over the past 26 consecutive years. With the rapid development of the Chinese steel industry, we see high-quality development. Let's see some examples. First, we have achieved breakthroughs in production of many key steel varieties. For example, TISCO EH36. Those are very advanced, world-class. We also see further improvement in steel varieties and quality. Second, there is remarkable progress in process equipment, which is key to achieving energy efficiency and low-carbon production. During the 13th five-year plan period, the steel industry has maintained its process equipment at the international advanced level. In general, we have equipment that is world-class.
Thirdly, we also see a clear improvement over the 13th five-year program, and we can see that merger and reconsolidation has improved. CR10 is 43% now. Fourthly, there continues to be a sharp improvement in green and low carbon capacity, and you see the improvements in energy efficiency. From 1980, the consumption of coal per ton of steel was about 2 tons, and it's now down to just over 500 grams. Now, you may be aware that the China steel industry is undergoing the world's largest restructuring. According to the highest standards over the 13th five-year period, particulate and pollutant emissions have all seen major decreases. Now, you can see here some of the pilot projects by some Chinese steel makers, green manufacturing facilities, and other examples where factories look very different to people's impression of a sort of large, dirty, disorganized plant. You can see very good examples of green manufacturing sites here. Now, smelting technology or metallurgical technology has seen some improvements as well. For the whole industry, there's been a concerted effort to experiment with and roll out low-carbon technology. Now, some of the key milestones are listed here. Some of the experiments that have been carried out, for example, Baowu, with its new blast furnace, and HBIS has gone into production now with hydrogen metallurgy, and there's just a few examples now of where they've moved from the research and development to an actual implementation stage. Now, this is the examples here you can see of, in concert with the low carbon development, you can see smart operation. You can see Baosteel. Over here, you can see that's called a dark factory. And you can see on almost automated and smart operation there. Now, it's easy to understand the Chinese steel industry just in terms of capacity, but actually it's been moving fast very quickly in technological terms. It used to be seen as going through 3 stages at the same time. Acceleration, reduction of capacity, restructuring, and greater environmental protection are happening at the same time. Now, the second part of my presentation is about progress and future possibilities in low-carbon transformation. This is the overall goal set down by President Xi Jinping, and you can see here how it translates into specific policy goals. And these are binding goals, and absolute binding goals that have been set just recently. Now, you can see various new concepts in the white paper on climate change in how to implement the carbon peak and carbon neutrality goals specifically in the steel industry. So that's a state-level, macro-level design which sets out specific ways that, through the policy framework, decarbonization is to be achieved, and the carbon peak is to be achieved at the level of the steel industry itself. Now, I'll give some examples of specific actions taken. Led by China Baowu, they've set up a global low-carbon metallurgical innovation alliance, and that's a global sharing platform. And you can see here, the secretariat is actually at my organization, the CMI-PRI. And that is a knowledge and technology sharing platform. Now, also the Industry Association for the steel industry has set up a standards, technology and development platform to achieve low-carbon development. And they've also started a steel industry EPD program with lots of steel makers that have joined that and they've submitted their own reports to that platform, and we are also trying to achieve international recognition on a mutual basis for that platform. Now, a fairly relevant forum here is the one that took place on energy efficiency benchmarking with the aim of improving energy efficiency. That involved the drafting of an action plan for the next 3 years and making sure that there are no areas left behind. Now, specific steelmakers in China have set out their own plans for carbon peaking and carbon neutrality. There's close to 150 steelmakers in China, of which I'll mention 3. The first one is China Baowu. In 2021, at the start of the year, they released their own goals for carbon peaking in 2035 and carbon neutrality by 2050. Now, they talk about improving the share of clean energy in their own energy mix and more resource-efficient investment as well. And they talk about heat efficiency in hot air-driven blast furnaces in particular. Now, the second example is HBIS, Hebei Steel, which in March 2021 issued its own plans for that, and you can see that they are staged goals and paired with specific actions to be taken. When it comes to energy, they talk about diversification of their energy mix to support the low-carbon development path. Thirdly, Anshan in May 2021, and Steel Group issued its own plan, again with staged objectives. So they've put a timetable down for that, with optimization of their energy mix, and in particular when it comes to green mines, because they have many of their own coal mines, they have specific goals for their own mining sites. Now you can see that lots of steel makers have set out goals and plans in line with their own energy usage and mix in their own production facilities, and they're actually carrying these out. Now, moving forward, I'd like to talk about 3 points. Firstly, low carbon will be a leading light for further systemic developments and innovation. You can see here how low carbon development leads efforts to improve efficiency, cut pollution, and refine the industry chain. Secondly, we have set out a clear low carbon transition path, which divides into 5 things: green development pattern, energy saving, energy and process structure optimization, circular economy, and breakthrough technologies. And we will be continuing to work on those 5 fronts to move further down the low-carbon transition path. Thirdly, the Steel Industry Association has set out a technological roadmap up to 2060, which divides into various time periods and has goals for each. We have a technological roadmap, and it divides basically into 4 stages to achieve, on an incremental manner, the carbon peaking and carbon neutrality goals. Now, we have 5 key tasks for the future, which will be guiding our future work. Just in summary terms, firstly, we'll deepen supply-side structural reform so that you have a high-quality supply and demand dynamics taking place. Secondly, optimizing structure and process flow, for example, the use of EAFs and DRI and so on. And thirdly, using more low-carbon technologies such as carbon capture and storage. Now, fourthly, building a green and low-carbon full value chain. And finally, which happens to be the subject of your forum today, improved global cooperation in terms of low-carbon development for the steel industry. And I think that is very significant, and I'd like to thank you for your invitation today. We're very ready to work together with colleagues and peers from around the world to achieve better and greener development of the steel industry. Thank you very much for your attention.
Thank you very much, Dr. Li, for this in-depth overview of steel decarbonization in China. I think it, for me, it really shows how important the dialogue is, because the questions we are confronted with and the challenges are very much the same as in Europe. And also, the last slide, for example, it really reminded me, like looking at the supply side, the technology side, and the demand side, and international cooperation, reminded me very much of also the way we structure our approach when identifying the necessary areas to focus on for industrial decarbonization. Now this is my bridge to the next keynote speech. It also showed the relevance of industry actors to develop own plans, transition plans, and to work on becoming climate neutral. Because this is also the topic of our next keynote speech. And okay, I'm seeing he's running up the stairs right now, okay. And our last keynote speaker is René Mono. Mono. Yay. Thumbs up. Hi, welcome. Okay, I give him like a second to breathe. Mr. Mono has been an expert on renewable energy and the energy transition for several years, and is now Vice President Political Affairs and the head of the representative office in Berlin of E.ON, one of Germany's largest and also multinationally operating energy utilities. And during the last, I would say, 1 to 2 decades, the company has been in major transition, mainly driven by, I would say, market liberalization efforts in Europe and also the energy transition. And Renaud Mono will provide an insight into business transition strategies of energy corporates towards net zero. And please give Renaud Mono a warm welcome.
Yeah, good morning. Thank you for the invitation. Thank you for having me. I was blocked in the elevator. That's why I'm a bit late, and this was also a little bit my personal adventure this morning. But having met this challenge, I think I'm in good preparation and in good mood to give you some insights. Actually, I haven't prepared slides because what I want to say is something that is a little bit my personal view on the question: how can big energy companies, big utilities that have developed for decades, if not centuries, how can they make a shift and a complete change with regard to the climate goals? And E.ON is a good example, but you could also take other companies, especially German companies, as in Germany the political will to transform the energy sector is maybe a little bit more clearly formulated, I would say, than in other European countries, even though in the end, of course, we have one European target, and we need to discuss how we can meet this European target in achieving climate neutrality by 2045 or 2050. So my view is that in the past we had like a reaction chain between exogenous shocks, political actions, replying to those shocks, and then as a third element, the reaction of business. I mean, it always depends where you want to start, but if you look, for example, in the beginning of nuclear energy in Germany, I think this was a reaction also to the experience and to development that led to World War II. And therefore, nuclear energy in the beginning was really praised by politicians as being an energy form that delivers freedom, that delivers even peace, that makes countries less independent from fossil fuels. And the energy companies that were forced to develop nuclear energy didn't want to do so in the beginning. And the same is true for other eras of energy policy, if you like. So take climate change as major issue. Obviously, there were also exogenous elements, political actions on an international level, and only in the end, energy companies started to take climate change serious as societal challenge and also as a business driver. And in Germany, we have then the situation that we had the catastrophe in Fukushima, Japan, which all of you will remember. And then the German policymakers took the decision to accelerate the exit of nuclear energy. And here again, as the first reaction, energy companies did not reply to this political action, to this political decision, even though in this time for more than 12 years, so 2011, 2012, for more than 12 years, they would have been in a position to make a lot of benefit from renewables. And even they tried to do so. The big 4 energy companies in Germany, and the same is true also for other European energy companies, did try to develop renewables. But let's face it, if you have a large portfolio of different generation sources like nuclear, like coal, like gas-fired power plants, and you have some renewable activities, then you have also internal conflicts between the business cases of, let's say, nuclear and renewables, or coal and renewables. And therefore, just for an internal rational, it's just not practical and also logical to expect clear action of business leaders as long as it is possible to stay with this portfolio. And I think what the energy sector needed to learn after the Fukushima event was that this time it's for serious. And companies like E.ON reacted then also in a very drastic manner by deciding to spill off their activities that were non-compliant with climate goals, also with other longer-lasting energy policy goals, and to put all those activities in a new company. In the case of E.ON, they baptized it as Uniper, so Unique Performance, a little bit absurd, the naming maybe. The idea was to get rid of those activities that did not comply to the energy policy goals. And I think this was the only logical decision that you could take, because if they hadn't done this, we would have stayed with the internal conflicts that I mentioned for much longer. And I can see now, I'm still, as Julia mentioned, kind of new with E.ON, at least for E.ON perspectives. I will fulfill my second year within some months. And I have witnessed a lot of internal conflicts already when it comes, for example, to the heating transition. Big issue, big topic in Germany. And there are some voices saying, well, maybe hydrogen for district heating, for example, or for other purposes in the heating of buildings, residential heatings. Maybe hydrogen is a good option. This is what one of our units, E.ON Hydrogen, says, green hydrogen, of course. And the other unit say no, we prefer heat pumps. Yeah? And we believe in the electrification of the heating sector, the complete, or almost complete electrification of the heating sector. And those different views, which are understandable from a business perspective and also from their view as expert for one technology, could block the whole organization for a while. Yeah? But this is, I mean, a minor conflict compared to the conflict between renewables and coal, renewables and nuclear. So I think for E.ON and the other large energy utility, RWE, that we have in Germany, did the same, or almost the same, a little bit different, but the main idea was the same. For E.ON, it was really important that business leaders in this time, it's now 8 years ago or so, made this clear decision. And I would also say that if you compare our strategy, the strategy of RWE, the strategy of Vattenfall, the strategy of Iberdrola, to the strategy of other energy companies or mineral oil companies, for example, then the strategy of those energy companies is clearer than the one for the mineral oil companies. And the reason is that the political goals, especially for the electricity sector, were more clearly defined, have been more clearly defined. Maybe this is still true until today, and that against this backdrop of a clear political will, of a clear political objective formulation, against this backdrop, that it became possible to make those drastic decisions. And now it is that I think the fate, the success of the companies like E.ON, like RWE, like many others, really depends on the success of the energy transition. So for us, the biggest problem from a business perspective would be a failure of the energy transition. That's why as long as the political, and I can only say we hope for this, it's not that clear anymore, as long as the political majority, if there's a clear majority, political majority for driving the energy transition forward, our business strategy and the business strategy of many other companies will succeed. If political parties win the majority in Europe, in Germany, and other European countries that question the energy transition, and there are political parties that do that, then we will have a problem. But this clear business strategy, this clear turnover in our business, wouldn't have been possible without the drastic business decision that were made 8 years ago, and these drastic decisions would have not been possible without the clear political picture, the clearly defined political targets. That's my main message that I wanted to share today. Thank you very much for your attention.
Thank you very much, René Mono, for your, let's say, thoughtful keynote speech, which of course, directing us towards the role of a clear political framework brings us think tanks into action, I guess. Now I would like to invite all our guests to a 30-minute coffee break. And for all our speakers, panelists, and meeting co-host organizations, so Agora staff, it's photo time now. So I would like to invite you all here to the floor to take a picture. And we are going to see us at 10:30 European time, again here, with our first panel discussion, which will be on the state of play of industrial decarbonization. So please enjoy your coffee break and good talks. Welcome back, everybody. I would now like to invite our moderator, my dear colleague Isadora Wang, from our Beijing office, and the panelists on stage for our first panel discussion on the state of play of industrial decarbonization.
Welcome, everyone, back to our panel discussion. Today, I have with me Professor Stefan, Dr. Zhang Zhen, and online we have Dr. Thomas Becker from BMW Group and Mr. Guo Daqing. We're going to wait for a few seconds before we can see them on the screen. So for this panel, we are going to dive into the steel sector, both in Europe and in China, because as Stefan and Dr. Li Bing actually has mentioned in their keynote speech, the industrial sector is a very important sector for the global decarbonization and for other countries to reach their climate neutrality goals. According to IEA, global steel actually contributes to about 7 to 8% of the total annual CO2 emissions. And in China, of course, China produces 54% of global steel. In Germany and in Europe, there is a good base of steel production. And in Germany, there is a very ambitious goal of reaching net zero by 2045. And broadly in EU, we have a goal to reach climate neutral by 2050. So there is a big role for the steel sector to play in order to have a more fast-paced carbon neutrality future. So without further ado, I will just dive into our discussions with some guiding questions. My first question will go to Dr. Zhang Zhen. Dr. Zhang Zhen is the executive president of Low Carbon Integrated Development Institute from China EV100. She's actually an expert in the hydrogen sector in China. My question to you is that, can you share with us what are the major challenges to ramp up renewable hydrogen deployment in China? And how could the Chinese government address those challenges?
Okay, thank you, Wang Li. Okay, let's look at the current situation of renewable hydrogen. On the supply side first, China, as we all know, China is the largest producer and consumer country of hydrogen energy. And there is about 33 to 35 million tons of hydrogen supply per year. The current share of renewable energy is not very high, it's less than 2% at the status quo. But China's renewable hydrogen is growing rapidly. For example, to the end of July this year, there are a total of 42 renewable hydrogen projects under construction and processing, with a combined capacity is 586.7 megawatts and over 1 gigawatts of electrolyzer orders. Such projects are mainly concentrated in north and west of China. But now, there are still many challenges for China. The main challenges of renewable hydrogen deployment are in 4 aspects. First, the comprehensive cost of green hydrogen is still very high. And second, the economics of scale hasn't been formed. And third is the hydrogen infrastructure needs a lot of investment. And last, the system of carbon pricing and the green standard of green hydrogen, green ammonia, and methanol need to be further completed. China is actively facing such challenges and adapting a series of measures. Firstly, to reduce the comprehensive cost of green hydrogen, China aims to increase the share of green hydrogen to 15% to 2030, achieving an installed capacity of 100 gigawatts of electrolyzer, and realize about 5 million tons of green hydrogen in 2030. So we expect that in 2030, the cost of green hydrogen can be cheap enough to substitute the green hydrogen. Secondly, only by technological innovation can we promote the utilization of renewable hydrogen on a large scale, especially in the metallurgy, the chemical industry, transportation, and other fields. Thirdly, the hydrogen infrastructure such as the refueling stations, the pipelines, need to be well planned under the guidance of government, as well as the infrastructure grid is now being driven by Chinese leading entrepreneurs such as Sinopec. Last one but not the least, the carbon market is very important to stimulate the application of the downstream market. With the petrochemical, the coal chemical, the metallurgy, and other high GHG emission industry are included into the carbon market. We think the green premium of green hydrogen and its derivatives will be further valued and achieved. Thank you.
Thank you, Dr. Zhang. I think it sounds very promising that in China, by 2030, the deployment of green hydrogen will significantly ramp up for the steel sector and the chemical sectors to use. Another aspect actually for industry and especially iron steel decarbonization is actually from the demand side. Their downstream sectors, for example, automobile. Today we have Dr. Thomas Becker with us. So my next question is to Dr. Becker. Because we've all heard that BMW is contributing to a greener steel market by securing a green steel purchase with its partners around the world, like in China, for example, with HBIS. The demand from downstream sector is certainly a powerful driving force to move decarbonization agenda forward. In this regard, do you think you can share with us your assessment of the green lead market in Europe and maybe in the world? And also, how do companies such as BMW integrate their climate actions into your corporate strategies and goals?
Yeah, thank you very much indeed for the opportunity of this discussion. Cars have always been made of energy-intense materials: plastic, steel, aluminum, copper, you name them. With electrification, though, the equation is changing, because if we wouldn't take significant measures to bring down the footprint of our supply chain, we would have a much bigger footprint in the production of the vehicle, which would work, so to speak, against the advantage that we have in the use phase. Very clearly, electric vehicles are environmentally better than internal combustion engine cars, but in order to get the full benefit, you need to work in the supply chain. Having said that, if we want to be able to demonstrate as a company that we contribute to the achievement of the Paris targets, it is not enough to just change the drivetrain, but we need to work on our supply chain in parallel. And here we have been engaging over the last 3 years very many of our suppliers in all the sectors, be it battery cell suppliers, be it aluminum, be it plastics, and namely the steel industry. And as you rightly say, we are trying to collaborate with companies who have a clear ambition to also decarbonize. And in the case of HBIS, we have been agreeing on a planned way forward, starting with improvements at a rate of 10 to 30% reduction from this year onwards. And then a next bigger step, which is based on direct reduced iron in electric arc furnaces, which has a way higher potential to decarbonize based on the supply of hydrogen. And very clearly, this is all part of the low carbon value chain initiative that BMW China, our joint venture in Shenyang, and our purchasing organization have been launching in 2021 in order to intensely work with our Chinese supply base to bring down the carbon footprint. And we are really confident that we are going to achieve ambitious rates of reduction with our vehicles we make in China, not only for China, but also for export. And that's why we are rather optimistic about the future.
Thank you, Dr. Becker. It's not only necessary that we work together, like the steel sector works together with its upstream supply chain and also downstream sectors. It is also important that we focus on the policy side, especially in China, in its very unique economy. I wonder if Mr. Guo is with us. If so, my next question goes to Mr. Guo. like, we've heard a lot from Dr. Li Bing about China's action and plans.
我在。
Oh, 好的。We've heard a lot about how China has been planning to decarbonize its steel industry and how fast it's been moving with all the demonstration projects. Like, how do you perceive China's current efforts on the decarbonization of the steel sector? Do you think, together with the capacity control policies and the promotion of electric arc furnaces policies, is it enough for China to, realize its goals of peaking carbon emissions by 2030 and also meet the Paris goals?
好的，感谢阿高，感谢王秘书长。对于您提的，
Thank you very much to Agora for this invitation. Now, in answer to your question, I would just venture the following. Now, we used to talk about energy saving and environmental protection. A lot of companies were adjusting and refurbishing their equipment in line with those goals. Now, after the double carbon goals were set down, we had a clearer roadmap for the future, requiring us to set our own decarbonization goals. In particular, firstly, controlling capacity in order to reduce overall carbon emissions. Now, one steel maker, crude steel production was about 1 billion tons. Sorry, Mr. Guo, can you adjust your headphones or headset? Can you access by another means? Because there's a lot of sound interference coming through. All right. Well, why don't you just put a couple of questions to other panelists first?
Sorry for the interruption. We are hearing, we find it very hard to focus on Mr. Guo's response, so we'll let him try another device. And then now we turn to our other panelists. I would like first to open the floor for our three panelists to see if you have anything to add or comment on what others have already expressed. Yes, Stefan, please.
Yeah. Maybe one question to Mr. Becker. I think that's very important in the car engine and automobile industry is very important for decarbonizing steel as one of the important markets. So it's interesting to hear from BMW China. So my question would be, which is the role of standardization? So how important are standards, what green steel is, what sort of green steel, because that's also clearly defining. So how relevant is that for you? And maybe a second one also, what about all the Chinese companies? They are also very important. Do they follow the same path or do they have different strategies? That would be very interesting from my perspective.
And I can't elaborate on what the Chinese automotive players are doing, but what I can clearly say is that we have a very keen interest in the best possible transparency of the carbon footprint. So we have very different technology baselines in the different markets. We have higher shares of BOF steel in Europe than we have in the United States, where EAF, for example, is much stronger. We have different rates of scrap usage. We will see different levels and different maybe support policies for different technologies. So therefore, what for us is crucial is the common denominator, which is tons of CO2 per ton of product. We do not prioritize the question of what actually is green enough or what is sufficient improvement for different technologies. But very clearly, our focus is on the transparency and the comparability of the actual footprint. And this is why we engage actively in the conversation, how can we enhance transparency in the supply chain? In Europe and in Germany, we have been initiating what is called Catena X, which is with the contribution also of companies from the steel industry and companies who are using steel products, which is all about creating a digital infrastructure whereby you are able to more precisely calculate the footprint of components and parts that go into a car. The same discussion, the same ambition to create more transparency is also taking place in China. And we see huge potential for collaboration between the EU and China in this regard, because clearly we all know that averages that are out there today and with whom many of us work today are not precise enough and will also not support innovation sufficiently. So if we want a strong motivation to innovate for lower carbon steel products, the difference needs to be shown and needs to be accountable and reliable. And this is why the methods for doing that, for allocating the CO2 footprint that you have in production properly to different final products, is one example of the important discussions we are having and which we namely support in the dialogue between Europe and China.
Thank you, Dr. Becker. I think in China there is also some effort to help with the global standard of green steel and also in other sectors. I just want to quickly check if Mr. Guo is with us. No? Okay. Okay, then we move on to the next question. Actually, Dr. Becker, you have already answered one of my questions, which is is there still sufficient room left for Europe and China to cooperate especially in the steel sector decarbonization, given the new geopolitical tensions between US and China and the new dynamics in the EU's policy toward China? But I think you've already provided a perfect answer. I just want to check with Stefan and Dr. Zhang Zhen to see their view. Yes, maybe Stefan first.
Yeah, okay. From my perspective, of course, I'm not so deep into China, so that's difficult to judge. But I think it's extremely important to do that jointly for at least two reasons. On the one hand, we all know, as I showed, European industry is really going to decarbonize their business case, which is a challenge. Investing into new technology, which is expensive. The new steel will be more expensive in the beginning, and of course there's lots of fears about competition. And on the one hand, industries are under pressure to deliver green steel to automobile makers and other clients. On the other hand, it's not easy to really do that. Big risk is involved, and so doing that in an internationally harmonized way makes it much better, much easier, because then you can trust that the markets also, that you are not too far ahead, for example, which can be a danger. So that's very important. And on the other hand, of course, the climate will not gain a lot if we only convert parts of European steelmaking to green. So China, as has been emphasized, is really the biggest market worldwide. So I'm really curious on seeing what happens in China and what are the plans. We have heard very impressive plans from some companies in the second keynote, and also the policy list is very familiar to what we see here in Europe. So that's promising, but I would like really to hear more of that, whether China is also, how much China is on track to making their steel green.
Thank you, Stefan. Dr. Zhang Zhen, do you have anything to comment or add?
Thank you. I think there is a huge potential for the steel decarbonization in China. For example, by 2030, we predict that industry will be the largest consumption of market of green hydrogen, which will take up more than 60% of the whole green market. For example, the demand market for green hydrogen is mainly in the chemical industry and metallurgy. For the chemical industry, the application of green hydrogen will be 3.76 million tons. And for the metallurgy industry, the green hydrogen application will be more than 1 million tons in China, we predict. Also with the further cost reduction of renewable energy, renewable electricity, and the electrolyzer supply equipment, we think the cost of hydrogen production is expected to reduce to around 13 yuan per kilogram. So at that cost, about 2030, the price will be very competitive to compete with the green hydrogen to realize real sustainable application. Also, the carbon market will promote the carbon reduction value of green hydrogen, especially in the industry. So China also is accelerating the construction of CCER market, hoping to further development the carbon reduction projects relevant in the green hydrogen to into CCER relevant products. So all of such aspects will promote the application of green hydrogen to realize the industry decarbonization. Thank you.
Thank you. It's very impressive that Dr. Zhang Zhen has shared with us, like, her expectation is for green hydrogen to reach like cost effectiveness by 2030 already, which is quite promising. And I've also want to comment on what Stefan has mentioned. Like you said, it's very interesting that you said in Europe there is a sentiment of not to go too far like ahead of others. There's also the same kind of way of thinking in China among all the steel makers. Like we can see very good examples Dr. Li Bin has shared, but also in the vast majority of especially private-owned steel mills, many of the owners are very much afraid of being fallen into kind of a pitfall when they are moving too fast. So it's very interesting that we are having the talk today. I see that Mr. Guo is back online with us. So just to remind all of us, my question to Mr. Guo was your opinion on the current efforts of steel sector decarbonization in China, and would you think it's sufficient for China to merely focus on capacity reduction and also the promotion of EAF? Are these enough for China to reach its Paris Agreement goals? Mr. Guo, the floor is yours.
大家好，抱歉刚才断线了。
Hi everyone, good morning. The decarbonization of the steel industry in China is still ongoing. The focus used to be environmental production, now it's for carbon peak and carbon neutrality. There are three aspects to decarbonization. First, to reduce excess capacity. From 2020, the capacity, the output reached over 1 billion tons. Then the government put out a policy to cap the capacity. Now the capacity is dropping to around 1 billion. And all the provincial governments are also implementing the policy from the central government. The second aspect is advanced technologies. In the past, the focus was on resources. They first found where the mine was, and then they set up the factory there and build a city around it. As time goes on, things have changed. A lot of steel factories moved to the places near the sea. So they replaced carbon-intensive technologies and equipment. The third aspect is better management. So people are talking about ESG in the recent 2 to 3 years. The upstream and downstream companies are also realizing the importance of reaching ESG. When it comes to the capacity control policy and the development of EAF, I believe that the decarbonization goal is not just about the steel industry, but the steel industry is part of it. Using EAF and limiting the capacity can help China reach the dual carbon goals. It's alone is not enough, but it's going to help. Thank you.
Thank you, Mr. Guo. Because he's with us now, I would like to ask you a second question, Mr. Guo. We talked about China's promotion of electric arc furnaces, which is based on scrap steel supply. So there have been a lot of policies to promote the scrap steel circulation in China. And we all know that its pretreatment is being flagged as a bottleneck for developing EAFs in China, among all other factors. How do you think China should address this challenge for scrap steel?
Well, this is a global challenge. And as many of you know, the likelihood is pretty high today that steel that has been a car will go, for example, into the construction sector. We have vehicles where we reach a share of 30%, for example, of recycled steel that goes into new products. But we have to be aware of the fact that the best source for secondary steel today is post-production scrap, where you have pure material with a defined quality available. If we want to really be able to have much higher rates of post-consumer scrap, we need innovation in the sorting and separation technologies because, as many of you are aware, contamination with copper, for example, is one of the biggest factors that limit the usability of secondary steel for automotive purposes. And on the other hand, what we are doing as a manufacturer is to design vehicles in a way that supports that. Very clearly, this will only become effective when the vehicles we put on the road now go into recycling, but still it's an important job to be done. And the next generation of electric cars from BMW, the so-called Neue Klasse, where we have shown a first glimpse at the International Auto Show here in Munich last week, has been the first generation of cars which have been developed with also some design principles in mind, which support better recycling, namely questioning the need for highly complex composite materials that the automotive industry has been developing over the last 20 years in order to reduce weight and save fuel of combustion engine cars. So we are looking into the full equation, including the contribution of circularity. And as a result of that, we are going to see more monomaterials in the future than we see now. We will also try to build cars in a way that you can reduce, for example, the copper issue more effectively before things go into the shredder. So it really is a job that needs scientific projects. We are part of quite a few of them. We need investment into the recycling industry, and we need design at the end of the car that supports all of that. So there's not one solution, but clearly we need to have more high quality automotive grade recycled material at affordable prices.
Thank you, Dr. Becker, for your insightful comments on this question. I would like to also invite Mr. Guo to share his opinion on the development of in China. Like, is China scrap steel recycling on the same page as Dr. Becker has introduced, or is there other aspects you are seeing?
我对于德国的这个废钢供应了解比较少。目前
I don't have a lot of knowledge about scrap supply in Germany. China is currently encouraging the development of the scrap supply chain. There are many plants that are working on scrap cars. With the increase of scrap cars, there will be more scrap supply. Then this can be fed into the circular economy. The moderator just mentioned about breakthroughs on EAF. In China, the crude steel production is about 1 billion tons. The audio is the speaker does not have good audio. Because industrialization in China started much later, in fact 100 years later compared to EU countries and the US. The steel industry is also lagging behind. So there is a lack of scrap supply.
It is not possible to interpret due to the sound interference on the channel.
能够解决的目前这个瓶颈。谢谢。
Thank you, Mr. Guo. We briefly lost Mr. Guo for a few seconds. I think let me just quickly wrap up what he has said. Like in China, the development phase of scrap steel is like actually kind of very different from the European countries and the States. Mr. Guo told us China is kind of lagged 100 years behind in the accumulation of scrap steel, and that makes it hard for us, for China to really like ramp up its EAF deployment. But we have like policies in place, and we also have provinces that are running really good policies to do the pilot demonstration. So in the future, hope, like Mr. Guo is hopeful that the scrap steel will be able to supply like the accumulation of EAF deployment in China. And I can give you a figure actually. The Chinese government has been estimating the future supply of scrap steel. By 2025, the government is expecting to have 250 million tons of scrap steel domestically. And China has also been lifting its bans on scrap steel import from other countries. But of course, with the global steel transformation going on, scrap steel in the future will become more scarce and more competitive or raw materials. So we'll see. Thank you, Mr. Guo, for joining us while you're still traveling. I think we go with another question to Stefan, because I have saved him a very hard, very challenging question. It's related to your lecture, actually. You mentioned a lot of the decarbonization, industrial decarbonization experiences, and I see a lot of them are of relevant importance in China. For example, deep electrification, like you keep the decarbonization step by step, and you also like kind of save the natural gas supply from other industrial sectors for the energy sector, for the steel sector, sorry. And in China, we also tend to do the same thing, like to prioritize a green hydrogen supply to be used in the steel sector. So my question to you is, like based on the European experience, do you think there are any pitfalls that China should avoid in its steel transformation? Like if so, like what is that?
Yeah, that's of course a really difficult question for two reasons. On the one hand, I'm not that deep into China, and on the other hand, Europe is just starting the steel transformation. So there are lots of plans, scenarios, ideas, policy instruments and announcements, but so far we haven't done really a lot, so experience is still limited. But I think maybe three things that are very important from my perspective. The first thing is it's really important to explain and make these scenarios, discuss with many stakeholders, particularly in the European, German context. That's important that all the industry players understand and work on it. But it's not only steel industry, not only the steel value chain, the energy equation is big in it. So we also need the energy system to supply the green energy for it. So that has to be integratively thought. And also that means lots of infrastructure, and at least in European case, infrastructures need public involvement, need public policy, but also acceptance by a broader public. It's a regional issue. Again, stakeholders on the ground have to understand that. I think we have seen the impressive example from German energy industry by E.ON. Steel companies are also big integrative companies, and people are going to lose from the transition. So that has to be well understood, and I think that is a learning from Germany, Europe, which probably also somehow applies to China. And maybe, and for that to be successful, I think we need sort of directionality. So really need to know where are we traveling, where are we going, and also how ambitious are we. So that's important to have clear policy signals on the one hand, and on the other hand, to make that even more concrete, we cannot be fully technology open in the end. So you talked about sort of prioritizing these energy developments. I think that's difficult in market economies, but we also need to sort of send clear signal. In Europe, we now have many, also smaller industries, all interested in cheap, clean, green hydrogen to decarbonize. But for some of them, it's pretty unrealistic to get that at least soon, at least cheap. So to be more clear to them, not promise everybody everything, because that's not realistic. And I think that's also an important learning we have to learn and appreciate in Europe, but probably that holds also for China.
Thank you, Stefan, for your frankness. Before we open the floor to Q&A, I'd like to invite Dr. Becker and Mr. Zhang Zhen to see if you have any comments or responses to what Stefan has just mentioned. Okay, if not, I think we have a few minutes to answer questions from the audience here. I see a hand.
我补充一个问题可以吗？
Sure. Can we hold on to your question for a minute? Yes, Mr. Guo, please go ahead.
我补充一个问题可以吗？是这样的，刚才我听那个王丽女士介绍的时候说中国这个废钢进口的问题。
The moderator just mentioned about the import of scrap steel policy in China. In 2019, the import was stopped. It was called foreign rubbish. Then later on, we published a standard for renewable steel if the scrap steel can meet the standard, then it can be imported because the standard is very strict. The import is very, very limited, only 550,000 tons. Before the stop, the peak volume was at about 14 million tons. I think that policy probably also contributed to the limited supply of scrap steel in China.
Okay, I think now we are good to have a question.
Yeah, thank you very much for this interesting discussion. Dario Sultani from the Potsdam Institute for Climate Impact Research. I guess with a somewhat naive follow-up question. As we've seen in the presentation by Professor Lechtenböhmer, for example, part of the European policy mix that is envisioned also includes policy instruments to ramp up green lead markets, as we like to call them in Germany. And what that essentially entails is some sort of portfolio of instruments that will help the basic material producers to capture a green premium. So some sort of additional revenue from a green material. Is that something for the people that are more familiar with the Chinese context? Is it something we can expect for a Chinese market as well? That we could see something even just from the private side or with policy intervention, or is it something that is so unthinkable that we should not consider it in this context? Thank you very much.
Mr. Guo, do you want to take this question? Or Dr. Zhang Zhen, do you want to address what we have got in this question? Like, is there going to be a green premium in China for green steel in the future?
Okay, thank you. I think, as we all know, there are two main steel decarbonization methods. One is electrification, and one is hydrogen-based steel making. No matter what method, we need abundant and cheap green electricity and abundant, cheap green hydrogen. So I think there are a huge potential for China and Europe to cooperation in the green steel industry. Europe countries and China are both the main production and the demand regions for renewable energy and renewable hydrogen, as well as pioneer of such technology innovation. Also China has a first mover advantage in renewable energy technology and supply chain. It's currently the largest exporter of renewable energy equipment. We think China will also be a major exporter of green hydrogen derivatives and equipment in the future. So I think Europe and China can deeply carry out the green energy, green hydrogen trade and technical cooperation to realize the mutual recognition of green standards. Which will provide important support for the green low-carbon energy transition and industry decarbonization of both economics.
Thank you, Mr. Zhang. I can give you some of my personal perspective. Actually, we see a lot of good practices, like policy tools in the European countries. For example, the contract for difference. And we are thinking, like, part of the work we do at Agora is try to cast some influence into the policy making in China to promote industry sector decarbonization. We have seriously considered, like, if we're going to promote the adoption of kind of CCFD similar tools, but in China, like the current momentum for economy is not like to subsidize too much about industry. especially heavy industries, are kind of listed as energy intensive and pollutant intensive sectors, which are always like not enjoying some favorable policies in China. So if there are going to be these kind of policy incentives, that like steel sector won't be like high on the priority list. Okay, I see that we have some questions from online.
Thank you, Isa. Actually, there is a question from Gina Cao from online. This person mentioned the conference is talking about the decarbonization in a point of view on the potential impact on the coking coal demand in China. Has the coking coal demand already peaked in China, or would that still keep increasing? Thank you.
Thank you for the question from Gina Cao. I think Mr. Guo is actually the most suitable person to answer this question about coking coal. I don't know if he is still with us. Maybe not. Okay, I'll try to answer it from my point of view. Coking coal consumption in China is actually like a big part for the steel sector to be, to like reduce all the iron ore. Like as long as China still has maintains its huge 1 million tons of steel production and 90% based on BF route, which is like long process route consuming coking coal. At least I don't see a quick decline or a sharp decline in coking coal consumption related to the steel sector. But we are promoting, doing a lot of demonstration on EAF promotion, and also what Dr. Li Bing has mentioned, the Baowu demonstration of hydrogen-rich blast furnaces, and also the injection of hydrogen in blast furnaces. With this, if we can have a wide deployment of these kind of new technologies, the coking coal consumption could go down. But I still don't think it will go very sharply. Yeah. Okay. Okay, we have one more question from the audience on site. Okay, and two, and then we can't take more questions after the two.
Hi, my name is Alistair Alexander. I'm based in Berlin. I work on research under Reclaimed Systems. I've listened, and it's very interesting listening to these presentations. But it's very clear that the technologies we're talking about are, to put it mildly, very unproven at scale. And they require huge mineral inputs and raw material inputs, which we can't secure yet. And they require enormous energy inputs as well. What happens if in 5 years' time we find we can't decarbonize steel in the way that we hoped? Do we have a plan B for that? If we do, what is it? And if we don't, when do we start thinking about it?
Stefan, do you want to take the question?
Yeah, thank you for the question. I think you mentioned material inputs. So basically, for the steel making itself, it's not an issue. We need the iron ore. There is some issues about the qualities of the iron ore, because the direct reduction route needs sort of higher quality iron ore. So we need more improvement of the ores. There's also other routes currently being followed that you can do DRI with lower quality ores. So in the end, I think there are certain opportunities to overcome that issue, but is not fully solved so far. I think that's one point. I'm not sure how future routes, which are direct electrification, so electrolysis routes, are into the same problems or offer solutions to that. So that may be something in the direction of a plan B. But so far, I'm optimistic with the ore input that we will get solved that, because it's not that big problem. Rather, the problem is bigger, getting the ramp up of the renewables, which also needs certain minerals. All that, I think, if we do it in a clever cooperative way, are solvable. But there are clearly these issues. Energy is a big thing. but from a German perspective at least, where I can judge best, it's solvable. If we start with natural gas, which is still there, can be saved anywhere, and then go to green hydrogen, I think there are good prospects that we will be able to make green steel. But in the end, need a strong ramp up of renewables, what we need anyway. In Germany, in Europe, in China, the same. That leads to the infrastructure for electricity, for hydrogen. So the challenges are big, and I don't see actually a real way around that. We have certain strategies to cope with these challenges. Secondary steel, one of them, because it needs much less energy. But I don't see really, there is no real plan B. But there are lots of options in order to make that feasible, and we need to follow all of them.
Thank you for the question. Thank you, Stefan, for your answer. I see Mr. Guo is back with us. Do you want to comment on any of the previous questions from our audience?
Well, thank you very much, Isadora. Thank you to all of you. Now, we're just talking about coking coal. I'd like to come in on that. From the Chinese perspective, the long process is starting to dominate. If we look at the percent of scrap steel in China at the moment, it's only 20%. The rest is derived from iron ore. And with that being the context at the moment, electric arc furnaces cannot develop much. So what we're trying to do is develop EAFs in an orderly way in China, in line with the actual circumstances. We're moving in a gradual way to get that to happen. As things currently stand in China, the vast majority of steel plants are the long process ones. So I don't think the demand for coking coal is going to go down anytime soon in China. That's my answer to that question. I'd also like to come in on another point here on EAF furnaces. In China, the EAF industry faces a lot of bottlenecks at the moment. One of them is raw materials, supply of scrap steel, as discussed. Secondly, equipment, human resources, and technology have not been taken that seriously for quite a long time now, and that's part of the bottleneck there. So if you want production of EAFs in China to go up, then it's going to take time to get that to happen. But thankfully, the state is taking EAFs a lot more seriously. So in the near future, I think that we will be able to see a role for EAFs in Chinese production of green steel. Thank you. And they'll start to flourish.
Thank you, Mr. Guo. I think our time is already up. Sorry for not being able to take the last question, but the majority of the panelists will still be here, so we can have time to catch up later. Thank you, everyone, for your attention.
So, indeed, we are coming to an end of this conference, and it is my privilege and my great pleasure to share a few remaining last comments before we are all going to have lunch and closing this hot day, which is already ever getting hotter. So let me start with saying that I was really pleased and really intrigued by the depth of the discussions and the spirit of collaboration that we have seen over these past 2 days. Today it was about industry decarbonization, corporate net zero transition, and EU-China trade relations, especially in the context of CBAM, the discussion we just had, the carbon border adjustment mechanism. And I think we found that many of these technologies and processes in the field of industry are actually not that hard to abate, as many people tend to say, but we already have solutions and opportunities. And in fact, we might rather want to call them fast to abate instead of hard to abate, which we have done for so long. And I think our conversations have highlighted not only the necessity, but also the remarkable opportunities that lie within this transition for large and small enterprises, the net zero transition, is not only an ecological and human strategic imperative, but also, a strategic imperative, because it is about ensuring the long-term viability and resilience of companies in a rapidly changing global landscape. In all these topics over the past 2 days, our dialogue has exemplified the strength and the importance of the China-EU partnership in the field of decarbonization. And to me personally, this is really serving as a beacon of hope and inspiration in times when signs of global warming are more and more obvious to all of us, as we can see in the news almost on a daily basis. So one takeaway for me of these past 2 days is certainly that we must carry forward these discussions. Industry decarbonization is certainly an integral component of the transformation of our economies to net zero. So let us carry this forward in the spirit of the cooperation, the lessons we learned here today, and let our actions be guiding the commitment we have expressed. Before finally closing this conference, I would like to express my deepest gratitude to all participants for your interest, for your contributions, and your engagement. And a big thanks goes to the organizers, the technical team, the interpreters, stenographers, the photographers, the cameraman, and above all, to my own team of Agora Energiewende, all my colleagues who made this conference possible. And I would like to ask all of you for a hand of applause for the organization team. And finally, I would also like to thank our co-organizers and partners, the GIZ, the Deutsche Gesellschaft für internationale Zusammenarbeit, the Shanxi Energy Research Institute, and the Shanxi Dual Carbon Energy Institute. So with this, thanks to all of you, I wish you a wonderful rest of this hot day, and please join us for lunch outside of this room. Thank you.